aesthetically, it looks better around the home. But more importantly, the benefits of the unit modulating from 35% to 100%. So, please look at this. I've sent you some information. I'll be sending out some more following the meeting. But with that, Joel, why don't you take it away?
Well, Randy, I appreciate that good introduction this morning about the product and all. Thank you for that. If everyone will notice, I have stopped the streaming on my camera. That gives us a little better streaming for you participants. They're going to be going with the training this morning. In addition, we're going to be recording this morning, and so you'll be able to go out after we record this session, and within an hour or two, it should be out there on our YouTube training channel. And what I'll do is I'll fire that to Randy, that link, and then he can forward that link to you. Now, today's training will be titled HMH7 17 SEER Heat Pump Overview, and then it'll have a date code behind it of 07/15/2021, so you'll know specifically which training session we did and recording we did. So with all that said, let's go ahead. I'm going to share my screen, and we'll go ahead and get with our training this morning. And Randy, I'm going to let you kind of be the moderator this morning a little bit, as far as if there's any questions or anything on the chat box, as well as to make sure that all of the screens and stuff come up okay.
Yep.
Okay, Randy, can everyone see that first screen okay?
Yes.
Okay. Well, again, good morning, everyone. We're going to be doing our HMH7 17 SEER heat pump overview this morning, in case we had someone join a little bit late. The first thing I always like to ask everyone to please do is to remember that the unit service gauges, or the unit service fittings, are actually the 5/16 flare. And you're going to have an adapter to adapt down to your service hoses. So if you take a look at the little picture there on the left-hand side, you'll see there's just a picture of it. And there's several companies that make these. For instance, the Yellow Jacket, Robinair, or just a couple, JB Industries, I think they make one as well. But what it is, it's a 5/16 female flare adapter going down to a 1/4-inch male flare adapter for your service hoses. So please remember that if you're selling these units or you're installing these units, to be sure and have that adapter so that you can hook your service gauges up to the outdoor unit. Okay, so there's several setups that we're going to be talking about today. The first one we're going to kick off with is with an AE air handler, Now, as a quick overview or a quick reminder, the AE air handler features what we call a standard ECM motor. Now, team, anytime you see that word ECM, we're talking about a high efficiency motor. Now, please make a note of this, a mental note, or just write it down someplace. The HMH7 heat pump will only be rated with ECM type of motors. Now, what I mean by that, it'll be rated with a standard ECM motor or a variable speed indoor blower motor. So any of our products that are ECM motors or variable speed motors, we should have a rating with this outdoor unit. There may be a few exceptions when you get into furnaces, but for the most part, any of our ECM indoor motor products should work fine. We're going to talk about the low voltage wiring with an AE air handler with a simplified block wiring diagram. And I want to make note also that the AE air handler has no actual physical screw terminals, but it's equipped with pigtail connections. We're going to talk about the wiring accessory of a single pole double throw relay in the indoor unit and how it's going to be used for airflow reduction. We're going to recommend kit number HMH7AK001 for convenience and the supplied parts. Now, it should be noted the HMH7AK002 relay kit may be used. However, the RV or one of the relays will not be needed for this particular application. So please write this down. If I was going to stock or have just one kit, if I had the 002 kit, that's kind of considered, in my opinion, a universal kit. It'll work on anything. However, the 001 kit will only work on the standard ECM motor type of products, for instance, like the TME furnace, the AE air handler. Those are standard ECM motor products, and the 001 kit will only work on those. However, the 002 kit will work on variable speed motors. It'll work on standard ECM motors. It'll work on a TME furnace. You get the idea. So we just need to remember that if we're going to have a standard ECM motor, the 001 kit is fine. But if you're going to have a variable speed motor, the 002 relay kit has to be used. However, the 002 kit can be used on anything. It's just you won't use one of the relays on there with a standard ECM motor. Just wanted to get everybody introduced to that real quick. Is there any questions or comments on that before we continue?
None in the chat, Joel.
Okay, sounds real good. Also, team, please remember the heat pump thermostat is going to have a BO selection for reversing valve operation. So any of your standard heat pump thermostats, your favorite heat pump thermostat, 24-volt thermostat, whether it's a Honeywell, Robert Shaw, whatever your favorite brand is, should be compatible. But please make sure that that thermostat has a BO selection, because we're going to be energizing the reversing valve in the heating mode of operation instead of the cooling mode. Now, that's not bad, it's just a little bit different. And so we'll be getting into all that here shortly. Okay, let's go ahead and talk about wiring up this AE air handler. Now, I might point out we're going to literally go in wire for wire. So this is pretty technically oriented, but at the same time, as we follow along, you'll start seeing the logic of how this is wired up. So we have a standard heat pump thermostat on the left-hand side, our AE air handler in the middle, and then our HMH7 17 SEER heat pump sitting outside. So starting out, we're going to energize that B terminal for heating mode of operation, for reversing valve heating mode of operation. So we're going to take that B terminal, or that B wire, straight outside. We're not even going to touch the air handler. Now, obviously, we'll probably pass through because that makes it simple from an install standpoint. But B goes straight outside. It doesn't even touch the air handler in this case. In addition, team, please remember this AE air handler is equipped with pigtails. And in our example, we're going to be featuring a 2-stage heat strip in this AE air handler. The W2 will go from the thermostat straight to the indoor unit. It will not go outside. W1 first stage auxiliary heat will go to the indoor unit and outside. Now, it should be noted that W1 is going to serve two functions. It's going to be first stage auxiliary heat during normal heating operation if we need auxiliary heat. So we can get a W1 call from the thermostat for auxiliary heat call. Or when we go into defrost, that's why we have to bring a wire from the outside unit into W1, the W from the outdoor unit inside, so that during defrost, we energize that first stage of heat strip, because as we all know, on a heat pump, when we go into defrost mode of operation, we're really going into the cooling mode of operation to defrost that outdoor coil. We certainly don't want to freeze the homeowner out, so we need to bring on some auxiliary heat during defrost. That's what that W wire from the outdoor unit coming in is for. Y terminal, this is very straightforward and conventional. Y terminal is our compressor call. Now, please note on the AE air handler, most of the time you're going to find a factory installed yellow wire going down to the standard ECM motor. That yellow wire needs to be removed if it's so equipped. So that yellow factory wire, if so equipped, is going to be removed from that ECM motor as we wire this up. C is our 24-volt common. And as I said, this is very straightforward or very conventional in the industry. C is 24-volt common. R is 24-volt hot. Again, very, very conventional, easy to remember. Now, it should be noted that R terminal does not, let me say it one more time, the R terminal does not go outside, because the outdoor unit uses a little different wiring scheme than we're used to seeing on our other Champion products. And so we do not take the R wire outside to the outdoor unit. The outdoor unit does not require to have that 24-volt hot going outside. What it's going to be doing, it's going to be utilizing the Y terminal whenever we call for compressor operation. That's really what's going to be driving our low voltage control outside, is from the Y terminal. E is going to be our fan call, and it's very, very typical on this AE air handler that we select the lowest speed tap or the lowest operation on that indoor motor, and that's very typical. So when you have a G call or a fan call only, what's going to happen if the thermostat, someone's got something kind of ringing in the background. Well, not real sure what that was. Thank you. Okay. So the G call from the thermostat sub-base assembly, if we call for fan-only operation, we want that ECM motor running at its lowest speed for just circulating air. Let's say, for instance, the homeowner's got some IAQ products and they want to circulate that air all the time. So on this particular air handler combination, we're going to use that G call on the lowest speed tap. Is there any questions or comments so far on this very typical wiring up to this point?
You have nothing in chat, Joel.
Okay, sounds real good. Thank you, Randy. So this is where we're going to start getting a little bit different from our other products. We're going to have this little a relay kit, if you will. In this case, we're just utilizing like the 001 relay kit. So it's just a little single pole double throw relay. And what we're going to do, we're going to take one side of that coil, typically B on the coil of the relay, and we're going to go to S1. Now that S1 from the outdoor unit is actually a command from the outdoor unit to reduce airflow. And we're going to show you how all that works here in a little bit with some of our animations. So that B terminal of the coil, or one side of the coil, goes to S1 from the outdoor unit. The A terminal, or the other side of that relay coil, is going to be tied into common, the 24-volt common. And so just imagine now if the outdoor unit was to energize S1, we're going to move or click that relay on a call for airflow reduction. The common terminal on the relay is going to go to Y. So basically, we're going to have a compressor call in order for that C, or that common on that relay, to be energized. Now, please note, we're going to select the high speed tap. We're going to select the high speed tap on the ECM motor anytime we have a W1 call. So if we have an auxiliary heat call, we want to drive that ECM motor to its high speed setting. That's typically terminal number 5 on the ECM motor. And that makes perfect sense, because if we're running the unit and we have an auxiliary heat call, we don't want to overheat that heat strip. So anytime we have a W1 call or an auxiliary heat call, it's very, very typical to drive the ECM motor to the high speed tap. The normally closed contact on the relay, we're going to go over to the ECM motor, and we're going to select a speed tap on the motor to provide 100% cooling airflow. Now, team, please write this down or just remember this. We're always going to design our ductwork, from an airflow consideration. We always want to design our ductwork for 400 CFM per ton. And we want to set up our normally closed relay contact for 100% airflow, 400 CFM per ton of cooling capacity. So if I have a 3-ton unit outside, I want to have this 100% airflow set up at 1200 CFM. If I have a 2-ton unit, I'm going to have 800 CFM and so on. So 400 CFM per ton based on our ductwork, as well as the 100% cooling airflow call off that normally closed contact on the relay. The normally open contact on the relay, we're going to go over and we're going to select a speed tap on the motor to provide 60 to 65% airflow. And that's correct. So what happens is when the outdoor unit is in a point of modulation where it needs reduced airflow because it's going into reduced capacity, as it modulates down to around that 50, 60 or so, 70% capacity, it's going to energize S1 and command low airflow or lower airflow. And sure enough, so when we switch that relay, which we'll animate for you here in a few minutes, when we switch that relay, we'll go to 60 to 65% airflow, that reduced airflow to better match the capacity of the unit when it's calling for reduced airflow under lower points of modulation. Any questions or comments on this so far?
Joel, there was a question. If the utility has a power management program, how do they break the power?
As far as to the outdoor unit?
Yes.
That's an excellent question. I'm going to have to show my ignorance because I don't really know. I've never been involved with the power management type of setup. Now, when I was in California, what they would do, they would just break it. They would shut the outdoor unit off. But for the life of me, I don't remember if it's on the line side or the low voltage side. How is it typically done? In the area of the folks that are asking this question.
Kevin, do you currently know how it's done with your utility?
Because if they,
on the low voltage side.
Low voltage side. Okay. Thank you for that good clarification. Like I said, I apologize. I didn't know how they were doing it. But if I was going to do that, I would probably break the Y terminal, because it's the Y terminal from the thermostat that drives outdoor operation. As a matter of fact, your S1 and your W out from outside and all that is actually driven by the Y terminal. And so they I won't say steal it, but they actually use that Y signal to drive those other control functions. So if I had to break one wire outside to have like load shedding or something like that, it would be the Y terminal. Good. That was an excellent question. Any other good questions or comments?
That's it right now, Joel.
Okay, good. Team, let's go ahead, and you noticed I did a little animation. I shifted the PowerPoint, and now we're energizing S1. Now, S1 is a command from the outdoor unit to provide low airflow, or to command low airflow inside. So we notice that when we energize S1, the input from the outdoor unit actually switches that relay and commands reduced airflow on that normally open contact. Now, one thing I will like to remind everybody, and please note this, if we have a W1 call that's present, what will happen, the fan will be on high speed, and essentially it will have no effect if you have an S1 airflow reduction. So let's say, for instance, the unit is in a lower point of modulation with S1, and then all of a sudden we get an auxiliary heat call or a defrost call, and what's going to happen is it's going to switch that motor to high speed. Now remember, team, the ECM type of motor, if it receives more than one speed command, let's say, for instance, in this example, it has a G command, it has an S1 command for lower airflow, and then all of a sudden you get an auxiliary heat call or a defrost call. So what's going to happen is the ECM motor, even though it has 3 speed commands, it will always take the highest of those speed commands. That's called airflow priority. So that's kind of one of the neat things about ECM type of motors. If it has more than one speed command, it will always take the highest command that it's receiving. In addition, please remember, team, that W1 will be present with the thermostat auxiliary heat call or during defrost cycle. Any questions or comments on this basic block diagram that we've shared with you this morning on the AE air handler and how all that works? Any questions or comments?
Nothing in chat, Joel.
Okay, well, fantastic. Well, team, at this time, we're going to go ahead and start looking at some low voltage block wiring diagrams on the TME and the TMY standard ECM motor furnaces. And so this is important because, these outdoor units, if you have like a dual fuel application, this is a really, really great product because it's not only, heat pump application, but you can do a dual fuel application as well. So we're going to talk about that low voltage wiring with a TME and a TMY type of furnace, again, with a simplified block wiring diagram. And it should be noted the TME furnace is a single stage furnace, as a quick reminder, and the TMY is a 2-stage heat furnace. Now, please write this down. Make a note of this. We currently do not have a TMY 8 matchup with this product. We do have TM9. We do have TM9Y, but we do not have the TM8Y setup right now, or matchups right now in AHRI. But as far as the TME and the TM9E, TM8E, TM9Y, but we do not have the 8 Y matchups in AHRI, just for everyone's benefit. So please write that down. We do not currently have that as a matchup. Now, the wiring accessory single pole double throw kit is going to be the same thing in the indoor unit for airflow reduction. As a quick reminder, the 001 is going to be recommended if you have a standard ECM type of motor. The 002 relay kit will be used for variable speed. And again, if I was going to have a universal kit on hand, it would be the 002 kit because it'll work on anything. It's just that if you have it on an ECM type of motor product, just a standard ECM motor product, you will not use one of the relays. But for like I said, kind of a standard or universal kit, the 002 kit works on anything. Now, please note the heat pump thermostat has to have that BO selection for reversing valve operation. In addition, please select the heat pump thermostat with dual fuel function if you're going to use it with a furnace product. It's very, very important. The heat pump thermostat has got to have a dual fuel function because we don't have dual fuel functionality, if you will, on the outdoor unit. It's a very simplified wiring outside. We don't have some of the advanced dual fuel features like we would have like on an HL19 or something like that. But that's okay because most of the time we find that most of our contractor base is very, very comfortable with having the heat pump thermostat as their dual fuel control. So please remember that BO selection for reversing valve operation and a heat pump thermostat with dual fuel function if you're using it with a furnace product. Any questions or comments so far on the chat before we jump into our block wiring diagram for the TME and TMY furnaces?
Nothing in the chat box.
Thank you. Okay, team, what we're going to do, we're going to start out with the TME furnace. Now, the TME is a single stage furnace. And so you'll notice it just has the one W terminal. Now, please bear in mind on the furnaces, we have hard terminal connections. So these actually have terminal connections. And again, a quick reminder, you'll notice on the left-hand side, a dual fuel thermostat will be required for this operation. So just like we had before, we're going to take B, that's going to go straight outside. That'll be our reversing valve in the heating mode of operation from the thermostat. Anytime we're in the heating mode, we'll energize the B terminal from the thermostat. W2 will not be used because it's a single stage thermostat. W1 from the thermostat will be going over to W1 from the thermostat will be going to W on the furnace and then W outside. Now, please remember, team, we have to carry that W from the outdoor unit back in order for the furnace to go into heating mode of operation during defrost. Just like we had before, Y is our compressor call. You'll notice this looks a lot like the air handler we just talked about, but the terminals are a little bit different because it's a furnace and they're hard screw terminals. C remains 24 volt common, just like we had before. R is going to be our 24 volt hot, and remember, team, it does not go outside on the product. G will be our fan call, just like we had before. Again, very, very straightforward. And other than the terminal identifications a little bit different, you'll notice it is pretty much the same wiring that we had on an AE air handler. B, or one side of our relay coil, goes to S1, just like we had before. A, or the other side of the relay coil, goes to 24 volt common. Again, this is where it starts, again, it's very common. 24 volt common from the Y signal from the thermostat to the outdoor unit will be going to the common terminal on the relay. Very straightforward. The normally closed contact on the relay will go to Y/Y2. Now, what we're showing here, the Y/Y2 is just how we have that terminal identified on the furnace, and what that is, that's going to be our high-speed cooling call, So even though the TME furnace is a single-stage heat, it actually has two-stage cool capability. This is a great furnace. I'll tell you, I really like this furnace a lot. It's a great product. Been very, very reliable for us. The normally open contact on that relay is going to go up and hit Y1, which is our first stage cooling call. And again, when we set up our furnace, we're going to be looking for high speed cooling, 100% airflow on the Y/Y2 output on the board down to the motor. And then the Y1 output, or the low speed cooling from the board, will be about 60 to 65% airflow, just like we had before. So remember, team, with the contractor, when he goes in to set all this up, he's going to still have to commission the furnace like he normally would, as far as any sort of two-stage cooling product, about 60-65% airflow on Y1 and 100% airflow on a Y/Y2 call. Now watch this. The only difference between a TMY and a TME furnace, we're going to keep the wiring exactly the same. So you'll notice when I went to this next screen right here, we just kept the exact wiring. It's the same relay. Everything stays the same. The only difference is the TMY furnace. You'll notice on the low voltage wiring, it's going to wire exactly like the TME, except the TMY is a two-stage heating product and requires a W2 and a W/W1 terminal. So the only difference between the furnace that we just did and this furnace here, the TMY, the two-stage furnace, is we've got a W2 second stage heating, so W2 from the thermostat over to W2 on the furnace, and then W1 from the thermostat goes to a terminal that's labeled W/W1. And so you'll notice that that goes from the thermostat to W/W1 to W outside. So basically, TMY and the TME furnaces are going to wire exactly the same on the relay. That's why I didn't bore you to death by going over all those wires again. It's the exact same thing. It's just the TMY furnace has got a W2, and that W1 terminal is identified a little bit differently with the W/W1. Any questions or comments on the low voltage wiring before we move the relay and show you the animation on an S1 reduced airflow call? Any questions or comments on how we've wired up these two furnaces?
No questions here, Joel.
Okay, sounds real good. All right, team, if we kind of watch closely, we're going to see that we're going to animate, or we're going to move that relay. So when we get an S1 call, with any of our standard ECM motor furnaces, when we get that S1 call, it's going to energize that relay. You'll notice that it's going to switch that relay and command reduced airflow on Y1, or that first stage of cooling. So very, very simple. Again, very straightforward. Wires up essentially like our AE air handler, except that we've got hard terminals on the control board, and they're labeled a little bit differently. Okay. The final setups we're going to be talking about, an AVC air handler, and then the TMV variable speed furnace. Now, please remember, team, anytime you have a variable speed product, you have to use the 002 kit, the HMH7 AK002 kit. You have to use that because it has two relays on it, which we'll talk about more in a little bit. So we're going to look at the low voltage wiring with the variable speed air handler and furnace with simplified block wiring diagram, just like we did before. Now, it should be noted, some of the terminals that are not going to be used on the outdoor unit, we're not going to be covering those specifically, because that'll be a board setup that you'll actually set up on the board itself inside, like you would any other variable speed. So to give an example, the HUM terminal, the HUM terminal, and the DHUM terminals, or the EAC terminals for electronic air cleaner, it doesn't relate to this outdoor unit, so we kept it simplified. Those EAC terminals and HUM terminals are going to be hooked up like you would just normally for any other variable speed product you've ever put in. You're still going to deal with that humidifier terminal and that dehumidifier terminal and your electronic air cleaner terminal. And again, that has nothing to do with any of the functionality or the wiring of the outdoor unit. So we're not going to be talking about those terminals that for a humidifier, for instance, because that's going to be strictly an indoor function of an accessory product that you may or may not even have. One more time, remember that HMH K002 kit is required because it has the two relays on there, and we're going to recommend you use that kit for convenience and for supplied parts. Now, please remember, team, because we're again, we're on a furnace. We have to have a heat pump thermostat with a BO selection for reversing valve, and we want to select a heat pump thermostat with dual fuel function because we are using a furnace product. So let's start out with the ABC air handler. The ABC air handler is a variable speed air handler, and we're going to go ahead and feature a two-stage heat strip today. Now, please notice down below, you're going to see there's actually two relays on this little board. There's a little board that this 002 kit, it'll come with two relays, but those relays, even though they're mounted on a board, they're going to be designated as the RV relay, which means reversing valve relay, and you'll see how all that works here in a little bit. And the S1 relay, the S1 relay will be the one that we're going to be using to switch speeds, if you will, for reduced airflow on the S1 relay. So there's two relays on this 002 kit, but let's go ahead and start talking about wire for wire, just like we did before. And then we'll entertain some questions. And we also want to make sure we talk about some airflow considerations with these units before we conclude for today. So let's go ahead and start out with that B terminal, just like before. That B terminal is going to go from the thermostat straight outside. W2 is going to go to W2 on the indoor unit, just like we had before. Again, very straightforward. W1 is going to go all the way through. W1 to W1 on the air handler to W outside for auxiliary heat call. Just like we had before, our Y terminal is going to go straight outside. We'll make some connections internally as we did before on our relays, but we'll get to that in a minute or two. C is 24 volt common. Again, very, very straightforward, just like we had before. R is 24 volt hot. And again, team, remember, it does not go outside. Even with the variable speed product inside, we don't take that R terminal outside. E is our fan call, just like we had before. Now, at this point, we're going to go ahead and start looking at wiring these relays up. And so one side of the relay coil, in this case, we're designated the A of the coil, because if you look at a wiring diagram and our install information, this is coming right out of our install information. We've just kind of color coded the wires a little bit, and we've made it easy to look at on the PowerPoint. But so we're going to connect both sides of the relay coils to 24 volt common. And so we're just showing that as the A is the A of the coils is going up to 24 volt common. Oh, gee, Joel, that was different than before. That's okay. It's just one side of the coil. Just please remember, team, whether you use the A or B side, it's academic because it's one side of the relay coils have to go to common. The other side of the relay coil on the S1 relay goes up to S1 on the outdoor unit. Again, this looks very similar to what we just did with a single relay, but you notice we've got two relays now. C terminal on S1 relay. C terminal on S1 relay goes up to Y. So anytime we have a compressor call, we're going to energize that C terminal on S1 relay. The normally closed contact on S1 relay goes to Y/Y2. That's our high speed airflow. That's 100% airflow command on our variable speed product. Our normally open on S1 relay goes to Y1, which is our first stage cooling call, which is going to be 65% airflow on a variable speed product. Now remember, team, when you set up your variable speed product, you're going to have some jumpers on there that's going to allow you to set up the airflow based on the tonnage of the outdoor unit and so on. So that's going to be the same variable speed setup you've done all along as far as setting up your airflow, tonnage of the outdoor product. And the unit automatically knows that if you have a Y1 call, it's going to drive that variable speed fan to 65% airflow. If you got a Y1 and a Y2 call, it's going to drive it to 100% airflow that you've got set up on those jumpers. So you're going to set your variable speed product up just like you've always done. And then when it sees a Y1 or a Y2 call, it'll make the appropriate action as far as airflow reduction. Now this is where it's a little bit different on the RV relay. On the RV relay, we're going to take and we're going to make a connection on the B terminal so that when we have reversing valve operation in the heating mode, we're also going to energize the other side of the relay on the RV relay. So basically that relay is going to be switching whenever we get a heating call on B terminal for the reversing valve heating operation. We're going to switch that RV relay, switch those contacts. Now watch this. The common terminal on the RV relay is 24 volt hot. There's going to be 24 volts there all the time. The normally closed contact on the RV relay energizes the O terminal. Now, this is why we have to do this, because on a variable speed product, you're going to have this capability of there's going to be a little switch, or there's going to be a jumper on the variable speed product. It's going to say HP for heat pump or AC. Now, watch this, team. If you have it on a heat pump, we've got to tell the variable speed indoor product that it's on a heat pump, so it knows to look for the O terminal energize the reversing valve on our normal product in the cooling mode. So by default, the indoor unit thinks it's in the cooling mode. But now watch this. When you energize the B terminal for heating mode of operation, we're going to switch that RV relay and break that O terminal. So now the indoor product says, oh, I'm in the heating mode. I've got the compressor call, and I know what's going on, and the outdoor unit's working, and I've got a Y1 call and so on. But it's the O terminal. It's the O terminal on the reversing valve portion that tells that indoor unit that it's in the cooling mode of operation. Now, team, real quick, somebody opened up a mic. I'm getting a little bit of feedback. So if everyone would kind of go ahead and check their mics and make sure they are muted, please. Randy, can you still hear me okay?
Yeah, I can hear you, Joel.
Okay, everything's still looking okay. Any questions or comments so far?
Nope, we're good.
Okay, fantastic. All right, team, so what we're going to do, let's go ahead and notice something. The TMV furnace low voltage wiring is exactly like the AVC air handler, except the terminals are a little bit different. So in other words, we have like a W/W1 on the furnace and so on, but everything stays exactly the same on the TMV furnace as far as the wiring as we had on an AV air handler or the variable speed air handler. So at this time, team, let's go ahead and remember that that we have to have a dual fuel thermostat on the furnace. And at that point, let's go ahead and do some animations for everybody real quick as you take a look at the PowerPoint. We notice that just like before, when we have an S1 output from the outdoor unit, we're going to switch the S1 relay and we're going to command low airflow, or we're going to command 65% airflow. So that doesn't change. What is a little different than before is we do have an RV relay. Now watch this. When we switch the RV relay, in the heating mode of operation, all that RV relay is doing is it's breaking the O terminal on the variable speed indoor product to let the variable speed indoor product know it's in the heating mode. So remember, on a variable speed indoor product, we have to tell it it's on a heat pump or straight air conditioning. And if it's on a heat pump, it's looking for that O terminal in the cooling mode, And if we back the animation up, you'll see right now that's in the cooling mode of operation. But if we go to heating mode of operation, we energize the B terminal for heating mode of operation. We switch to RV relay. We break that O terminal. We break the O terminal on the indoor product, telling the indoor product we're now in the heating mode of operation, which is important for certain advanced functions as far as the humidification function and stuff like that. So O drives some advanced features on the indoor unit that we have to break in the heating mode of operation. Any questions or comments on how we're hooking up the variable speed indoor products as far as low voltage wiring and the utilization of the 2 relay pack, the 002 kit? Any questions or comments so far?
Nothing in the chat box.
Well, fantastic. Well, team, before as we kind of start winding our training down a little bit, we try to keep the training to about an hour, and then we open the floor up for questions. But please remember that on every install, to confirm proper airflow, I just cannot stress this enough. You know, this is a great product. The HMH7 is a modulating heat pump. So it's going to modulate from 40, 50%, 35% all the way up to 100%. And I think it even has a little bit of an overdrive function. But it becomes very, very important to have proper airflow and proper duct size with this, because as we start modulating down and as we start modulating up, we have to make sure and provide the proper airflow. Now, here's what would happen. Let's say, for instance, we had a 5-ton unit and we had really lousy ductwork. Let's say we had a 3.5 ton duct system and a 5-ton unit outside. What the outdoor unit's going to do, because it's constantly monitoring suction pressure and it's looking at suction line temperature and liquid line temperature and discharge temperature and outdoor air temperature, it's looking at all these parameters simultaneously, and then it makes intelligent decisions on modulation. So let's say we had a unit that's outside. Let's say it's a 5-ton unit outside, but we have inadequate ductwork. What's going to happen? The unit's going to see lower suction pressure, colder suction line. It's going to see a cooler liquid line, and so on. So what's going to happen is the outdoor unit's going to automatically see a reduction in capacity inside because it has lousy airflow, and it's going to start modulating back. So here you have this unit outside doing what it's supposed to do, but we're not getting the full capacity inside because we have lousy airflow. So I just can't stress this enough, that on every install, we have to confirm proper airflow. And because the HMH7 is a modulating unit, nominal airflow is very, very critical. Now remember, duct size and ductwork has to be able to provide 400 CFM per ton of total capacity. So in my example, if I had a 5-ton unit sitting outside, I need ductwork to provide a 2,000 CFM of capacity on that indoor unit. So it's very, very important that we always consider the airflow when we hook one of these things up, and make sure that the duct system's able to handle the proper size airflow. Now, it should be noted, most of the time, it's been my experience in the field, most of the time, even if I can't get to my supply duct, if I can at least get to my return, maybe I can add a couple of returns, or maybe I can increase the size of my returns. We want to work, we just want to be aware of this and work very, very hard to make sure we provide as close as we can humanly get it to proper airflow if we want these things to operate properly and function the way they're designed. Any questions or comments on that before we kind of round out the day and open up the floor with some final questions? Any questions or comments on airflow considerations?
We're good here, Joel.
Everybody good? Well, team, I'll tell you what, as we kind of wrap it down, I'm gonna go ahead and stop sharing my screen. And this will give everybody the opportunity at this point, if they do have any final questions or comments, let's give everybody just a minute or two, and I'll turn my camera back on so we can, kind of conclude our training today with a smile, so to speak. But is there any final questions or comments before we stop the recording and conclude for today? Everybody good?
Remember, guys, again, this unit will achieve up to 18 SEER and 10.5 HSPF. So I'll be emailing those facts out along with some more information and ratings. I believe I attached the ratings for the furnaces. I'll be attaching all the ratings for the air handlers as well. And I'll put the link in there that you guys can review the presentation again. And I'll also send out approximate availability of the product as well.
Well, fantastic, Randy. Thank you for moderating today. And I want to thank everybody. If there's no further questions, I want to thank everybody for your participation today. And please reach out to Randy and myself and all of our champion team if we can answer any questions for you, if you have any application concerns or whatnot. But with all that said, thank you, and everyone have a great day and be safe out there.
Thanks, everyone.